students. In the last lecture, we discussed about the timestamp algorithm and all. But before that, before discussing all the concurrency control and transaction processing techniques, we have discussed about the situation of the situation where the recovery is required, database recovery is required. We have also discussed about the system logs or why log files are required. Now, uh, what is recovery actually? Why is recover? What is the recovery? What the recovery means? Recovery in database terms means that bringing the database to the last consistent state of the database, or you can say stable state of the database. So whenever there is a failure that occurs, then we'll have to recover the updates done by the transaction and bring it to the last stable state where it was. Okay, that is what the recovery means. So there may be many reasons for which the transaction may fail, but before failing, the transaction may have updated many of the data items. So these data items actually, the values, the new values, which are actually written by the data items, are stored in a file called as the system log. Now, to recover, the system log is consulted, and the last stable state is obtained by using those obtained values from the system log. Okay. So, typical strategy for recovery may include, out of two situations, maybe one of the two situations where, depending on the strategy of the recovery may be taken. One is the catastrophic failure, when there is a lot of damage being done by some catastrophe that has occurred. It may be a fire, it may be earthquake, it may be anything, any catastrophic failure. So if extensive damage is done to the stored data because of such catastrophic failure, then it may be such catastrophic failure like disk crash, etc. Then what is done is that the data is restored first by bringing it from the archival storage, because data is actually periodically taken backup of the data, maybe after a regular interval with a period. The data is basically backed up in some archival storage. Those may be actually tab files. Okay, so they are basically large offline files or offline capacity storage media where it is being backed up regularly. So from there, from archival storage data is taken and it is restored first to the new system. Okay, once it is restored there, then the log file is consulted to redo the operations to bring it to the most recent stable state. Okay, because log file contains the data that are being written or updation done by the transactions which were running at that moment of time. Those recent updates are stored in the log file, particularly those transactions which has committed their operations. Now, those data are retrieved from the log file to redo to the to the operations which are stored in the archival storage, because archival storage are basically relatively older, because maybe say after a few days, always say after 2-3 days, there is archival storage done for the database for the okay. So whenever archival storage is brought to restore the data, then it will have the data which is maybe 2-3 days old. Then to bring it to the most recent stable state, maybe some 1 hour back a recent state, or maybe few minutes ago recent state was there, which is a stable state before the catastrophe has occurred. So to bring it to this recent state, the log file may be applied to redo the operations for the transactions. Okay. Now for non-catastrophic failure, the recovery strategy may be actually to identify any changes that may have brought inconsistency to the database. Okay, so undoing those operations which has brought inconsistency to the database may be enough to bring it back to the consistent state. Okay, so for non-catastrophic failure, maybe some programming fault, okay, maybe some exception conditions. So all those non-catastrophic failure, maybe undoing of the some operations may be enough to bring it to the recent most stable state. Okay, of course there may be little bit of redoing of some operations may be required to bring it to the consistent state. For non-catastrophic failure, the two main techniques of the recovery may be distinguished as either the deferred update or immediate update. Now, what is a deferred update? Deferred update means whatever a transaction changes on any changes that makes a transaction makes to the database item, those changes are not immediately written to the disk. They are basically stored in the buffer space in the main memory. Okay, they are uh, they are written to the disk only at the commit point. That is when the transaction reaches its commit point. So uh, then only these are written to the database on the disk. So when then after the commit point, basically it writes, and that is why uh, since if before commit point the transaction fails at any moment of time, those changes need not be undone because it was never written in the disk. So it was only in the buffer space. So if it fails, the transaction fails at any moment of time before the commit point, then the disk written is, since the disk written is not performed, it was not originally written to the disk, it was only in the buffer space in the main memory. So you just have to, you don't have to do anything, uh, undo anything. Okay, so this method is also called as no undo method because the transaction waits till the commit point to write it to the disk. There may be some redoing of some of the uh, outputs may be required to actually give effect to the actual storage in the disk. So it is basically that's why this particular technique is also called as the undo and the redo algorithm. Undo oblique redo algorithm. Okay. So this redoing is basically is done from the commit, this operation of a committed transaction from the log. So from log some redoing of the redoing operations may be necessary to give, you know, to bring the database to a consistent state. Okay, so that is why it is called as the no undo redo algorithm. So there is another uh, technique which is called as the immediate update. Okay, so immediate update means before the transaction, the before the commit point, the transaction basically writes to the disk. Any update that is being done, the transaction can write to the disk. Okay. At the same time, it also writes to the log file. Okay. So that the whenever if the transaction fails, the recovery may be done by consulting the log. In the immediate update technique, basically this writing to the log file is actually called as the force writing to the log file, because whatever the item that is updated to the disk, because it is not yet committed, so that particular updation has to be written to the log file so that the recovery is possible if the transaction fails before it commits. Okay, so to roll back, basically this log file is the only source, so log file will be consulted and the whatever update was done in the disk will be undone. So this algorithm also is called as the undo redo algorithm. So because the redo is there, because some redoing of the operation may be required to go to the recent stable state of the database. So both undo and redo may be required, and for both the log file has to be consulted to do the updations. So this is called as the immediate update. That you remember one thing, that is the uh, that among the two techniques for the non-catastrophic failure for the recovery, deferred update means where the commit where the transaction waits till it is being committed. Okay, till then whatever updation was done, that was only stored in the buffer space, not written in the disk. In the immediate update, it is written in the disk, but then the log file is also simultaneously updated by force writing of the log files. Okay, so in the deferred update, there is, even if the failure occurs, you don't have to do anything. No undo is required because it is only in the buffer, so not updated to the disk. So there is no question of undoing. Whereas in the immediate update, undo is required because it is being written to the disk. So the log file is consulted to undo the operations. Redo a little bit of required in both the techniques, in the deferred update as well as the immediate update. Transaction rollback and cascading rollback. When a transaction fails, for any reason for which the transaction has failed after updating the database, but before the commit operation, then the transaction needs to roll back because commit is not performed. It has only updated some data items. So since commit is not performed, commit means giving the final saving to the data. So after commit, you need not roll back because commit actually is the final state of the saving of the transaction data. So it is so if it fails, transaction fails before the commit operation. So those updates has to be rollback, which it has done. Okay, and that is those values which it has written just before this updation is done. That means it must be restored to their previous values. That means those data items for which the transaction, suppose transaction T has failed before committing, then whatever was the previous item of that particular data item X, which was written by the transaction T, that previous item value has to be restored. Now, if a transaction T rolls back, okay, then any transaction S, any other transaction S, suppose T and S are two different transactions, which has read the data which was updated by T, that particular transaction must also be rolled back. Okay, that means if the transaction T has written some data item and that was and because it has failed, the values has to be rolled back. So if it transaction S, some other transaction has read those values which are written by the failed transaction T, that particular transaction must also be rolled back. Similarly, if there is some other R transaction, say this R as you can see here, R transaction, which actually reads the updation done by suppose S, then this R also updation must be rolled back. So this sequence of rolling back, because some transaction in the which has earlier done some changes has failed, is called as the cascading rollback. That is, cascading rollback is basically like sequence of rollbacks that is to be done because of some transaction failed in the chain, and that particular method is called as the cascading rollback. There is another very important technique for recovery purpose that is called as shadow paging. In the shadow paging technique, what is done is that database considered to be some fixed set of pages, say n. Okay, n is a constant, so we consider the database to be a fixed size page, disk pages of the n number of disk pages. Okay, so uh, after that, a directory is created to indicate to each of these pages. Suppose there are n number of pages as we have considered here. So there is 1 to n number of entries in the directory. Okay, there is a directory which is being created, and this directory contains some index values that is there from 1 to n. Okay, so these are basically each of the index value actually points to the different pages in the database. So among the directory entries, the ith entry basically points to the ith page, suppose. Okay, we can consider the ith entry point to the ith database page. So that way the directory is created. So as the transaction starts executing, starts executing, the directory is, there are two directories actually which are being created. One which is where the transaction is currently executing. Another is actually copied from this directory as the shadow directory. So we make basically two copies of the same directory values, one which will be modified by the transaction as the transaction goes on executing different operations, and another is the shadow directory which is actually separately saved in the disk. Okay, so if the file is smaller, so small in size, database file is small in size, then this directory can be stored in the main memory only, the current directory, and the shadow directory is written to the disk and saved to the disk. Okay, so once during the transaction execution, this shadow directory is never modified. It contains the initial pages of the database before the transaction executed. Okay, as the write item operations etc. are being performed by the transaction, this current directory pages are only modified, and they are basically the old copy of the pages is not overwritten. Actually, only a new pages of the um, only new pages are created, and those are basically overwritten. Okay, so current directory in this pointer or the index basically indicates the new pages which are being created and where the new values are being stored. As you can see in the diagram here, these are the two directories. Okay, actually they are both the copy of one another before the transaction started executing. Now the shadow directory is stored in the this shadow directory is stored in the disk. Okay, now the page 1, the 1 value indicates to the page 5. Okay, this one. So directory 1 indicates to the 5. You can see the 5 is the old page. The old is written here to indicate that it is the old values which are there. And when the transition started executing, if any values are modified in the page 5, suppose there is some modification being done to the page 5, the current directory value will be basically pointing to the page 5 new. Okay, it is not mandatory that here it is the, so uh, you can see here it is the first page is indicated by page 5 here, this one. Okay, this is the 5 index, and here it is this one, the same 5 index here, which is actually pointing to the new page which is being created. It's nothing but actually copy of the page 5 with the new values. Okay, so updated values are in the page 5. So this is pointing to another disk block. These are basically main memory disk block where the modifications are being done. So these are not stored in the hard disk where the original values are stored. So shadow directory is basically stored there in the hard disk. But thing is that shadow directory points to the old pages, and the current directory points to the new pages, that is the newly assigned disk blocks where a copy of the original page is done and the new values inserted, updated. Similarly, in the page 1 is not modified, so both the directory basically points to the page 1 with the same value, that is here also 1 points to page 1, here also 1 points to page 1. Page this one 4 is also not modified, so both 4 index and 3 points to the same page 4, but page 2 is modified by the transaction. So any data item that is stored in the page 2 will be in the shadow directory. It will be the old values, old index value which will point to that shadow directory, and there is a new page being created which will be pointed to by the current directory because there is some updation here. Okay, so contents of the value page 2 is copied to the new page, and the new data value which are being updated will be made changes there in this particular page. Page 5 is basically indicates this one, page 5. Okay, uh, page 6 is the same, it has not been changed. There is no data value stored in the page 6 are remain the same, so both the directories will have the pointing to the same index location of the page 6. Now, to recover from the failure during transaction execution, suppose the transaction has failed uh, during the execution. So what has to be done is that only the current directory needs to be discarded, and old directory, that is the shadow directory, needs to be restored. That's all. Because if the current directory is discarded, anyway it was referring to the new values changes which were being done, because they are nothing but actually copied values. So this will get discarded. So there is no reference to those pages which were being changed, whereas the original directory, shadow directory, needs to be replaced. No, current directory needs to be replaced with the shadow directory. That much only has to be done to reinstate the old values in the recovery process. So recovery process become very simple in this particular method.